Okay, so LLMDaL is trying to use large language models to convert unstructured network data into high quality label data sets. So why is this important? Number one is we need more data sets from real networks. There are not many out there. Number two, when you have, even if you have that data set, you need to still manually label the data set to make it ready for the AI use, and that takes a lot of time. And number three, when you have really nicely labeled and rich data sets that will enhance the threat detection, intrusion detection for scientific infrastructures that are using machine learning or AI-based approaches. So the infrastructure that we target here is MLIT, and MLIT is educational infrastructure that is connecting Latin America and Africa and the US, maintained by Florida International University. And we aim to produce label data sets from that network. It's a real production environment, and that's why the data will be very rich, and it may capture the patterns that do not exist in simulated or generic data sets. So potential risks for the project is, since we are using LLM labeling, of course, it can produce inconsistent results or hallucinations. And we are hoping to mitigate that through different mechanisms that we proposed in the proposal, like self-reflection and verification steps. But the payoff is high, because if this is successful, then it will give us a method to scale this data set labeling, and it will give us data sets from real-world scientific networks, and eventually that will eliminate or reduce the costs for manual efforts of labeling data sets. In terms of innovation, we are looking at the use of AI here, generative AI, LLMs, and obviously the goal is to automate the process and make it as accurate as possible, and create data sets that are ready to be used by machine learning approaches. The existing approaches that we have currently sort of incorporate some automation, but they are still time-consuming, they are not scaling, and they are not able to capture the complexity of real-world data. So what is interesting here in terms of innovation is, how do we customize LLMs to our needs by training self-refinement? We want to make sure that it produces accurate labels, because at the end of the day, we are relying on AI, and AI can generate inaccurate results. So the challenge here is to be able to refine those through different techniques, and we propose self-refinement, self-reflection. If that doesn't work, then it's elevated to expert verification. Some of them could be verified by experts. And finally, we are proposing to use an ensemble of different LLMs, so that, if some of them, they don't agree, then we do a majority voting. So these techniques are new to labeling process, and we're hoping that they will bring accuracy and speed to the process. For evaluating and demonstrating transition, there are a number of metrics that we target. Number one is, of course, accuracy. We want to make sure that the labeling that we do is accurate compared to expert annotations on benchmark data sets and real-world incidents. We are also looking at other metrics like identifying emerging threats, new threats, and also importantly, looking at reduction in time for labor and the like how much time we put to label and how much we can reduce it when we're doing the labeling. So the project will make the code and fine-tune LLMs and the labeling agent that we propose publicly available under open source license, so that other researchers can replicate it and build on them, and even transition to other domains possibly. This is a 3-year project starting in January, and Florida International University is involved because MLIT is managed there, and I will be at Virginia Commonwealth University helping to produce the LLM and do the experiments. That's it. Any questions? Any discussion?
So great stuff. This one, I think, this is exactly what this is a really good fit for, I think, some of the data set stuff we're talking about here. I believe this is going to be highly valuable data. I really love the idea of actually having the LLM labeled data. So I think, for the NDP OSDF teams, I think this one is going to be a very highly used, highly accessed data set.
Yeah, so. A quick terminology based on ignorance. When you say label, you mean you label the records in the data set, right? Or
yeah.
What are you labeling?
We're labeling, so when you would like to train a machine learning model, you need to feed labeled data that,
right.
This is a threat, this is normal, this is abnormal data, so that it learns.
Yeah, I understand, but the label is associated with the record in the data set. The data set consists of records, and each record has you attach to it a label, or what is the unit that you label? Is it a record in the data set? Is it a file? I don't know.
It's a network flow. Perhaps if guys from my team that they can answer that better. So there are network flows that we are getting, and we are labeling them that it's normal activity versus abnormal activity. But if
I answer that.
Yeah, go ahead, Julio.
Yeah. So this is flow data. We have data coming from the packet layer and the optical layer. It is identified, and it will be tagged with some label. It's not necessarily a record, but it will have a start and an end, and it will be used. There will be tags there that will then be used for training the LLM.
So I mean, I assume you're using the LLM to tag. First of all, then you are using this to train another model.
Well,
I'm trying to understand the end-to-end flow here, because how many records do you plan on training?
That could be. I mean, we have
tagging, not training. Sorry, tagging. I mean, AM Light. How many records do you generate, Julio?
We generate, it's real-time data, it's telemetry data, Marone. So we're talking about gigabytes of data on a daily basis.
Okay, so I will stop here, but how many records? Because each tagging each labeling is a task, right? Record label. We have been talking to others that say
a record, and the way you're using record, essentially it's a flow. Okay, it's the flow of an IP packet, with source and destination address. That's basically the unit of measure that will be used.
So you label each element in the flow?
Well, we identify events. Okay, like
Okay.
for example, a DDoS attack or any kind of event that is then used for training the LLM. We need to first be able to train the LLM as to what the different types of events are that are occurring on the network.
Okay, I will let others continue. I will need help here. Okay.
Well, and just two observations from me, and then maybe we can see if anybody else has any other quick questions. But so I think some of the interesting challenges here in terms of the data set availability is going to be I think some of the questions that Marun is raising here are things that will be worked out during the proposal. So I mean, AmLight has a massive amount of traffic flowing through, right? And I think refining the figuring out how to label the data is part of the research. And so I suspect on day one, Kemal and Julio have, probably a gigabyte of data being generated as we're speaking on this talk. But whether that's labeling, how they're going to change those labels, how that will evolve, what's the right granularity, I think is all part of the open research. And so that'll create an interesting challenge. From an NSF program standpoint, and the LLMDaL team, correct me if I'm wrong on any of that, but from NSF standpoint, we've got an interesting dilemma here, right? Which is, at the end of the project, we're going to have a lot of really cool data, right? In the interim steps, right, for the next 3 years, is it ready to, at what point is it ready to go out and not, and how does it update? So I think that'll be part of the data challenge. So I don't know, Kemal, Julio, am I getting that right, or what are you guys thinking there?
Yeah, I think you're right. Part of the research might be like what is the granularity of labeling? I mean, we're thinking with Julio is the network flows is the record that was mentioned. But there's a network flow has a lot of elements in it, so it's a huge data. So how we deal with it, that's part of the research.
Okay, so part of what you need to do is to identify the objects that you want to label, because eventually when you use it as an input for training, you provide the next level of training with records and labels. This is labeled as a threat and this is labeled as
Right.
So I
That's
understand
correct.
that, but you don't have a structure yet. You say, okay, I will take these 500 packets and create an object and label them, this is the threat.
That's the flow definition that Julio was referring to.
I understand. He has the flow, but he doesn't know the boundaries of what needs to be labeled.
Yeah. So let me interject that. So I think good discussion, but I think maybe we take some of this offline. I think what I wanted to get across here is kind of the start of the discussion with the OSDF and NDP teams, a little bit of awareness for everybody as sort of what kind of data is generated out of here. But
I know at least where Julio is, so I can find him.
yeah, but I think there definitely is a data story here to be had. So thanks a lot, Kemal. This is great. Let's hop over to the next one, which is I think going to have a little bit of similarity with AI CyberLake.